Assignment 4 is due on Sunday. Tomorrow is code review. Next week we have a test. We have the test Friday. The test will be of a similar format to the last one. So you should know what to expect for format at least. Yes?
What will the material range from?
Basically everything up to the end of section 1 of this document. So don't worry about section 2 from this document or anything after that. That will be, we'll save that material for the final exam. So, yes.
Does the stuff from test 1 be included or no?
Well, it's interesting, right? Because because this is a programming course, there's really not much I can ask you that doesn't rely on the material from Gesundheit. For example, it really doesn't matter what we do with Java. You're going to have to know what a class, what an object is, what a method does. You're going to have to know public and private, right? So yes, all of that stuff, you'll have to know what static is and does. Tomorrow, I think we'll have a big fat test review. I think that might be useful. Certainly, last time around, you folks voted to prefer doing the review this week as opposed to this time slot next week, which doesn't really give you very much time to prepare for the test after having done the review with me. So I think there's some wisdom in that. Certainly, I've said this before, I'll say it again, the ideal pattern for studying is to study maybe 20 to 30 minutes per day for a few weeks in front of the test. So, that's the way to activate your long-term memory. That's, a good study habit. Your study sessions should also include recall exercises from what you studied last study session. Okay, sure. But yeah, other than that, it's a Java test. Any questions about it? You then you. Yeah.
So, are there going to be more theory-based questions, like for example, the difference between inheritance association or polymorphism, like how it kind of works underneath, or is it more like just writing the code and?
You can expect this one to be similar to the last one in this respect.
All right.
Your question.
Could you describe the second test? Same level as the first one, harder, easier?
It's definitely going to be harder because the material is harder, right? As of test 1, right, we were really only kind of testing up to association-ish, right? Inheritance is a more difficult concept than composition. So a test on that includes material on inheritance is going to be a harder test de facto, right? So yeah, it's definitely going to be harder. Yes?
Final exam is going to be wherever we study from now until that week, or it would be about the entire course?
Final exam is comprehensive. However, once again, everything in the course is strongly cumulative, right? So, for example, one of the topics here, abstract classes and interfaces. This is material which is reserved for the exam. You cannot understand these without understanding inheritance. So, to some degree, by testing interfaces, I'm also testing inheritance. You kind of get what I'm saying, It's kind of like how at this point, I don't have to write as a question for you that tests if you know how to use an if statement, right? That kind of level, yes.
Will there be a reference sheet like the last test?
There will be a reference sheet just like the last test. Keep in mind, one of the topics which is covered on the test is the Java FX GUI stuff. There are a lot of, pre-baked, pre-built methods and objects and classes that come with that whole thing. You may have noticed there was a certain amount of reference on that for the last one, because that, our knowledge of Java FX has expanded, so too will the reference available for it, for example. Does that make sense? In fact, I think if I take a look at this module stuff, might as well release the review. Oh, wait, did I just? Yeah, that's fine, actually. Might just have it at the end of this thing. Yeah, there you go. This is approximately what you'll get for the test. Okay? This is included in the Test 2 Winter 2018 practice test document. Sounds good?
Yeah.
Good. Any other questions about the test? All right. Well, shall we keep going then? All right. So, we left off last week discussing the concept of subtype polymorphism, right? So, again, over the course of this course, we talk about several different types of polymorphism. We just got through talking about overloading and versus overriding, which are both forms of method polymorphism. Now, we are talking about polymorphism as it applies to types themselves. So, it's very important to understand that in Java, classes are types, right? Not only when we declare a reference variable do we use the name of the class we expect, but this is also enforced by the type check, right? If you have a method that expects a circle and you give it a rectangle, it's not going to compile, right? This is useful. So, things get a little bit more complicated because there is a relationship between inherited classes, one which they are. If we have an inheritance relationship between two classes, right? Let's say that we have class A and class B, which inherits from it. How do we say that arrow? Class B blank class A. How do we say that? What's the verb?
I just had it, I forgot it.
Is it extend?
Well, that's the keyword that we use in Java itself, yes, but there's a simpler one, yes? Is A, that's right. Class B, an object of class B, is an object of class A. This is as opposed to composition, where it's a has-a relationship. your RPG hero has a sword, right? A paladin is a player character, right? Actually, a pretty good way of thinking about this, like, I'd like to extend that metaphor just a little bit. So, in certain in certain video games, you have like character subclasses, right? So, you know, if you're looking at something like Dungeons and Dragons, right? You'll have cleric as a character class, but you have like a bunch of different types of cleric that you can spec into as options for the class, right? So, you know, you might have like a war cleric versus a nature cleric, right? Both of these are still clerics. Both of these classes inherit from the cleric class, right? Both of these classes can do all of the things that clerics can do. But they are still distinct things in and of themselves that have differences. Make sense? So, here's where things get a little tricky. You know what? Rather than do this on the board, why don't we do this in IntelliJ? Everybody get IntelliJ! By the way, I talked to Professor Kokegan about this, and he agrees. This concept is the single hardest concept in the course. Yeah, like subtype polymorphism specifically. If you get this one, it's all downhill from here. Not that it's easy in any way, but you know. So let's make some classes. Let's make class A. Sorry if I'm not feeling especially creative today. Class B. There we go. We've got class B, we have class A. Let's say that class B extends class A, thus establishing the inheritance relationship. Let's give these simple classes a couple of simple properties just to give them something, right? Let's say that class A has a public int x, class B has a public int y. Sound good? So far so good? Yeah? Good. Let's make a main function now, or a main class now. Question?
What's that first class? I can't really make it out.
The first class, A? This one?
Oh, just class A, got it.
Yeah.
Pretty hard to keep up because I felt like crap today.
Well, if it's any consolation, I currently feel like crap because I had to say goodbye to a friend, so.
Who died?
No, they just lost their job. Yeah, but it's still, it's like a kind of death, actually. You do go through a period of mourning. You know?
Are you talking about your fridge?
Not my fridge, no, an actual human. Someone in the department was let go, so, and not because they screwed up or anything, but because there's a bunch of cuts occurring at the moment. So.
That's the job force for you.
Yeah, well. I need to stop talking about this or else I'm just going to be angry. So, standard main function in a main class. The standard sort of way that we create objects from these two, class A is equal to new class A. No, nothing surprising there. Class B B is equal to new class B. Nothing surprising there. Here's something that might be surprising. Class A C is equal to new class B. This is not a syntax error. What about the other way around? Class B D is equal to new class A. That is a syntax error. So, the reason line 5 works and line 6 doesn't is because of the inheritance relationship between class B and class A. The variable C has been declared for something of class A. Something of class B is something of class A. Something of class B is something of class A. Therefore, something of class B satisfies something of class, it satisfies parts of the code where we want something of class A. But the reverse of this is not true. If we are saying that D must be something of class B, and we try to jam a class A into that slot, class B is a class A, but class A is not necessarily something of class B. Right? It's a little bit, let's go back to our long familiar crustaceans example. You remember our crustacean class that either lobster or crab could inherit from, right? A lobster is a crustacean. A crab is a crustacean. Another way of saying this, all lobsters are crustaceans. All crabs are crustaceans. Are all crustaceans lobsters? No. So if we were to say, I want a lobster, and you give me any old crustacean, that's wrong. I wanted a lobster. Right? You don't give me a shrimp, don't give me a crab, don't give me a pill beetle. I wanted a lobster, and I won't leave until I get a lobster. Your program won't compile until I get a lobster. That's what Java is saying right here. Yes?
Just to clarify, so line 5 is saying that you want a crustacean and you're getting a lobster.
That's right.
And then the one below it is you're saying you want a lobster but you're getting a crustacean.
That's right. Actually, I could change the names of these classes. That might make things a bit more clear. Refactor, rename. Let's make class A crustacean. Refactor. Let's refactor this. So, by the way, do you see what happened when I did that? When I used refactor from the menu? It went through and it replaced all instances of the use of that class name throughout all files with the updated name. That's very useful and very powerful because that, my friends, is where bugs come from. Operations like that, incompletely applied, that's where bugs come from. Like, probably 70% of your on-the-ground bugs that you will experience during development that must immediately be fixed come from copy-pasting code and not consistently changing X to Y, or trying to do it like a refactoring like that by hand and missing something. You all know what I'm talking about. You've all been there. You've all done it.
This happened to me.
Right?
Yeah, this happened to me on JavaScript.
You know what I'm talking about. So yeah, did IntelliJ as an editor just like go up in your estimation a few clicks? You know? Yeah. Rename class, call this lobster. There we go. There we go. Now, just for the sake of completeness, I'll make a crab class as well. There we go. Crab extends crustacean. Give it a public int z. There we go. So, yes. So on line 5, I'm asking for a crustacean. I'm giving it a lobster. Is a lobster a crustacean? Yes. So everything's fine. On line 6, I'm asking for a lobster, but I'm getting any old crustacean. That's not what I asked for. Does that make sense? This is subtype polymorphism. Lobster and crab are both subtypes of crustacean. Make sense? Good. So here's one for you. I'm declaring an array of crustaceans. Only 2 crustaceans in my crustacean array. This is also fine. You remember, hopefully, arrays in Java do not function like lists in Python. They are typically monotyped. An array of integers may not contain a string. An array of strings may not contain a boolean. An array of crustaceans must contain objects which type as crustaceans. But this is one of the few instances where you can like have a little bit of flexibility in Java, right? The array doesn't care what particular type of crustacean you are slotting in here, right? So we can have an array of mixed types, mixed subtypes, so long as they all have a common supertype that is either this or a subtype of it, right? Everything in the array has to type as crustacean, but you're allowed to have any sort of crustacean in the array. Does that make sense? So there are practical ways that this is used. It may not surprise you to know that in JavaFX, all of your GUI components inherit from a common class, right? One class provides, the basis for your labels, your text boxes, etc., your buttons, right? You know the root.addChildren method that adds all of the components to the root pane, that line? Have you wondered why it's strange that in Java you should be able to put all of these differently typed things into one method and it's fine? That thing is expecting values of the supertype, right? The common type. And it's accepting all of these different types of GUI components because they're all inheriting from that one common type. So that's how it works. That's how it works and maintains type correctness. Does that make sense? So, what's interesting is that all of this business that we're discussing has kind of no effect really on how Java runs, like the execution semantics of Java. What I'm teaching you are the type semantics, the type checkers semantics. So the type checker is responsible for making sure that you're using objects correctly, right? The type checker is responsible for making sure if you're trying to access, the integer x from the lobster class, that there is actually an integer x in there, right? That's the job of the type checker, among other things. You thought it was just checking to see if you were trying to assign Boolean literals to your integers, eh? Well, no, it does more than that. So, when we declare the C variable as a crustacean, this is an annotation to the type checker. Right? We are telling the type checker that the crustacean C, or that C is a reference to a crustacean, right? The runtime semantics, this makes precious little difference to it, right? All of these type annotations get stripped out. They aren't executed they're not compiled down to machine code, right? They're not part of the execution semantics. So, here we are labeling the variable with the type we want the type checker to think that this is. The type checker thinks C is a crustacean. The type checker does not know that C is actually a lobster. In order to know that, this would need to be executed. That's part of the execution semantics, not the type checking semantics. So, C has a variable y. It has it. It does. We declared it as a lobster. It must have the instance variable y. And yet, our attribute is red. Hover over. Cannot resolve symbol y. Very strange. Because C is a lobster. Lobsters have y. Yet, I am receiving information that this does not work. And that is a proper compiler error. That will prevent execution. So what gives? C has a Y. The type checker doesn't know that C has a Y. Y, let's see, this one has X, this one has Y, this one has Z. According to the type checker, C is of type crustacean. Things that are of type crustacean are not guaranteed to have a Y. Lobsters have a Y, crabs do not. Therefore, you cannot assume that anything of the crustacean type has all of the properties of anything that's inheriting from that type. Does that make sense? More or less? It comes back to all lobsters are crustaceans, but not all crustaceans are lobsters. Right? Not all crustaceans have the Y property. So, the type checker says, oh, this is just a crustacean. I don't know that this thing has a Y. I'm going to say no. Go back and figure yourself out. Does that make sense? Nevertheless, this is somewhat inconvenient, right? The best way to program, if the thing you're writing, like, okay, let's imagine we were writing a method, right? Public method foo, public method foo. I've been doing too much JavaScript lately. Public void foo takes a crustacean, right? In this context, I think it's fairly easy to see that crustacean, some general crustacean, does not necessarily have a Y, so that is a type error, right? All crustaceans have an X, right? Oh, except now I'm returning things I shouldn't, because it's a void function. There we go. So, we can, however, agree all crustaceans have an instance variable X. They all do. If your method requires Y, you should probably type the input as lobster, right? If your method requires Z, you should type your input as crab, not crustacean. If your method requires information from the subclass, it might be a method on the subclass, not on the superclass. You should try fixing these before resorting to the thing I'm going to show you. All right? Make sense? can use a test to determine what class a variable actually belongs to at runtime. The keyword is instance of. We are looking to see if the past crustacean is an instance of lobster or an instance of crab. Make sense? So, let's try it out. We'll actually have to declare our, oh yeah, actually we have these ones, right? So, d at 0, foo at d at 1. There we go.
Sir, you also have to get rid of the y.
Oh yeah, that's true. Yeah, thanks. Also, I think I have to make this static. Static. Public static void. There we go. So you can see our output for this one, it's a lobster. This one, it's a crab. Okay. We're getting there. We're getting there. Within this block of code, we can confidently state that C is a lobster. Within this block of code, we can confidently assert that C is a crab. But unfortunately, the type checker still doesn't know this. We have not changed the type annotation of C. So, there is a way to do this. You can, within one line of code, drop additional information off to the type checker. It's called casting. A typical example of casting, all right? Let's say we have the character A, and we print it. It's the character A. Okay. What happens if we cast it as an integer? 97. Why?
Is it because that's the ASCII number?
Precisely so. What? Whoa. Google shouldn't be asking me if I'm a human. Why is Google asking me if I'm a human?
I don't know why it happened with me too.
It happens with me every so often. It's just user traffic or something that they're saying is happening.
This is... Okay, fine. You just lost business, dude, Google. You just lost business. It's like this one asks me if I'm a human. So, here is your ASCII table, right? ASCII is the mapping from the numeric binary codes that all of these characters are actually stored in memory to the characters that we see on screen. You can see if you look at 97, there's our lowercase a character. So what happens if you take a character and you say, this is an integer and not a character? The underlying binary data is the same in both cases. The binary has not changed. What has changed is whether you're interpreting it as a character or as an integer. If you interpret it as an integer, you get 97. If you interpret it as a character, you get lowercase a. It's the same data in both cases. Is that clear? Does that make sense? Sort of, hopefully. Let me know if that doesn't make sense, because that's super important. I want a couple of additional pieces of information about ASCII. Hello. While we're on the subject, stuff I bet they didn't tell you. First of all, do you know where this encoding came from? It's the internal representation of the first electronic typewriters. Yeah, so you can tell this because in these codes up in the front of ASCII are like kind of weird operations, right? You'll see interesting ones here, right? Like line feed. What's a line feed? Right? Well, you're feeding the line on a typewriter. What's a carriage return? Macs still use carriage return as a new line character.
That's like new line, it takes you to it brings it back, right? Is that what it is?
Yeah, so on a typewriter, what's the carriage?
The thing that moves.
The thing that moves, yeah. So, oh man, I have to show you a picture of a typewriter now.
I've used typewriters,
Oh man!
Duct tape going.
Every time. Typewriter. Alright. This is a good one. Alright, so this is a typewriter. Alright? First of all, if you want to talk about ergonomic keyboards, this is about the least ergonomic keyboard that is possible to exist, right? Because you're supposed to have the keys angled away from you, right? But on a typewriter, you can kind of understand the way it's laid out because each one of those is mechanically connected to a print head, where like kind of like a piano, when you press the button, a hammer comes down and punches the ribbon that has like the ink on it, so that the ink transfers to the page where the hammerhead strikes it, and the hammerhead has the little impression of the letter that you typed. And that's how a typewriter works. All right? So that's the carriage, right? So the carriage was movable. The place where the letter was typed on the page was fixed, because look at the mechanics, right? So basically how it worked is, as you typed, right, the carriage moved over, and then well, actually it would go this way, and then when you got to the end of the line, you hit the return key, and that would return the carriage. And then often they would also ding, because they had bells in them, and that's fun. I don't know why they dinged a bell, but a lot of them used to ding a bell. It's like ding. It was very satisfying to listen to. Kind of like ratchets are very satisfying to listen to. So yeah, so that's where things like bell and carriage return come from in ASCII. Many of these values are no longer used. For a while, bell was mapped to like a hardware beeping device that you would have on your motherboard. So like back in the 90s, in the 486 days, when you booted your computer, it would beep twice. And that's why, because it was printing the bell character twice. As like, you'd hear like hard drive sounds like beep beep, and that's how a computer, like an old like 286 used to boot. But
Printers do that. Printers, they do that.
yeah, some of them do. Yeah. Yeah, like some of them do, some of them don't. A lot of them don't these days, but then again, a lot of computers don't actually shut down when you tell them to either. There's a sneaky little thing that Windows did. Did you know that the default action on Windows for some, I think since like Windows 7 even, has the default action when you turn the computer off is to not actually turn the computer off. It puts it into a deep hibernation state. Yeah, yeah, so like to actually get like a hard reset on the computer is like, you used to be able to enable it in the options, but I'm not even sure you can do that anymore. I don't know, I haven't used Windows in 10 years.
Windows is hell.
Yeah, Windows is terrible. I hate Windows. But yeah, so that's where ASCII comes from. That's where a lot of the values come from. That's why basically all of these map to keyboard buttons and nothing else, right? And basically the reason that they still angle keyboards towards us to this day is because that's what typewriters did. But yeah, so there you go. If you take a character and you say, this is not a character, this is an integer, it prints it as an integer. We can do the same thing with objects, although you do so at your own risk. You are overriding the natural and normal function of the type checker, which means you could introduce runtime errors if you're not doing it correctly. If I cast something that's a crustacean as a lobster, because it is a lobster, that's great. If I cast something that's a crustacean as a crab when it's actually a lobster, that's not great. Because the type checker will be looking for crab things when only lobster things are available. Right? Let me show you. Where was I? That's in this one. Yes, okay. So, I cast this as a lobster. Now here's the problem. It's still not working. I have, and this is a little tricky. That works. So, this is an unfortunate operator precedence thing. So, you've got two operators going on here, right? What are the two operators? Casting is one operator. What's the other operator we're doing here? Sorry? No, not operation. Within this expression inside of the print, we have two operators that are, yes?
To gain the y variable?
Yes, it's the period, right? Period is an operator. It's attribute selection operator, right? So we have an object, we want to get a method or an instance variable out of the object, we use dot. Dot is an operator, right? Dot binds more tightly than casting. So, what does that mean? It means that if you leave it ambiguous, right? Lobster C dot Y, you leave it ambiguous, you don't tell it which one to do first. It's going to choose this one, because this one binds more tightly. This is wrong, unless you're trying to cast Y as a lobster, that's wrong. So what do you have to do? You have to do the same thing you have to do every time the operator precedence betrays you, stabs you in the back. You have to specify which operation goes first using brackets. This is wrong, this is correct. Does that make sense? It's a little, it looks funny, but it does work. Again, let me just say, I do not find this preferable to overloading that method for these two classes. I'll show you what I mean. I'll show you what I mean when I, I still have to show this to you though. You need to know how to do this. You can't really call yourself a Java developer without having passed through this particular gauntlet. Right? That. Okay, sure, right? This, to me, this is preferable. Public, oh man, it's keyboard. Oh, my poor wrists. Public, static, void, bar, lobster, x, sure. Gesundheit. Maybe we'll call it lobster Q. Gesundheit. Right? This does the same work. It's more clear, it's more cogent, there are fewer stupid if statements floating around. You're using the overloading mechanism. I prefer this to this. Right? The other thing that's nice about doing it as two methods other than one, if you add another thing that inherits from crustacean, let's say we add shrimp, right? If you add shrimp, under this method, right, you'll still call crustacean and you'll probably forget to add one of these cases and you'll fall through the if statement and it'll behave badly and it'll produce a bug, right? Whereas, if you've used two methods, one for each type of crustacean, that, my friends, is enforced at the level of the type checker. So if you try to call the bar method on a shrimp and there's no definition for shrimp, it'll tell you there's no definition for shrimp before you compile it, right? Which is good. So I think that's better, right? But, it's up to you. Maybe you think this is better. If so, I think you're a fool. But, so it goes. Does that make sense? All right. All right. See, did I get everything? All right. It actually is. So. Let's discuss how subtype polymorphism interacts with method overriding. In the crustacean class, let's give it a toString. Did you know you could just do that? You could auto-generate that. Maybe I showed that to you already. There you go. Crustacean says crustacean. Lobster says lobster. All right. If we print lobster B, what do we think happens? Will it say crustacean or will it say lobster? How many people think crustacean? How many people think lobster? Opinion is split. Let's see. It's a lobster. So, again, type checking semantics are not the same thing as execution semantics. Even if the variable has been typed as a crustacean, that doesn't change how it behaves. If you call a method on a lobster that it's overriding from crustacean, you get the overridden version. Even if it's been typed crustacean. Right? Because that's execution semantics, and typing is type semantics. They are two different things. One is native to the compiler, the other to the runtime engine. Make sense? Any questions? All right. Good. I did actually talk about everything in this section in various ways. There's another example basically trying to motivate this idea of being able to make one array for all of the subtypes, right? You can imagine how complicated things get, right? Let's say we had, that's probably too small for you to see, just give me a second. Let's say we have a class diagram. Person inherits from object. This is not terribly significant. All things inherit from object. Employee inherits from person, and student also inherits from person. Faculty and staff both inherit from employee. A general description of people around the college. Let's say that we had to write something for, I don't know, billing people for parking, right? All of these people have to pay for parking, right? Do we want to have to write a version, like write a data structure out individually for each of these different collections of people? Or would we rather say, you know, according to parking, there's an employee rate and there's a student rate, right? It makes sense to collect things in sort of the data structures that are convenient for the algorithm. You guys want a hint about data structures and algorithms, the course that's going to destroy you in fourth semester? No? Not that bad?
It's not really that bad.
Which semester?
Fourth semester, data structures and algorithms. Yeah, I'm being somewhat facetious. It won't completely destroy you, but it will definitely wreck your social life for a semester, right? Yeah. So it says, the title of the course says data structures and algorithms. It is a mistake. It is a drastic mistake to think of those as being two different things. You know, like cheese and onions. It's not like cheese and onions, data structures and algorithms. The algorithm is the data structure in a lot of cases, and the data structure is the algorithm in many cases, right? Like, you only arrive at the data structure through the algorithm. The algorithm only applies to that data structure, right? Maybe not with like sorting regular lists, but like the more you go through it, the more that's the case,
Yeah, I can see what you're getting at.
right? Like think about, they don't do binary, do they do like binary search trees?
They do in the Introduction to Intelligent Systems class. Yeah, they do all the searches.
Yeah, so like there is no binary search tree without the without the algorithm that applies to it and constructs it, right? Like some algorithms apply to general data structures. Many of your kind of normal sorting algorithms do that, and I know the course focuses on those. But like once you start getting into stuff like there's no real distinction between a B tree and the thing that operates, like the thing that gets data out of a B tree, right? There's very little semantic distinction between those, right? At a certain point, data structures and algorithms fuse into one thing, right? But anyway, the point is, rather than keeping these 3 arrays of these 3 different things, you could keep 1 array of all of these different things and decrease the amount of bookkeeping you're doing. And that Java does this in the standard library frequently, right? I already mentioned the Java FX example. So, yeah, okay. All right. I want everybody to just take a deep breath in. Breathe out. In again. Out again. Cleanse your energy, right? Put a mental bookmark, because all of that is test stuff. We are now crossing over the threshold. This is now exam stuff. Okay? Sound good? So, abstract classes and methods. So, I've hinted at this. If you consider a class diagram to be a description of reality, it's a system of categorization, right? This is most obvious when we're doing things like crustaceans, lobsters, and crabs, but it is also hopefully obvious in an example such as this one, right? Student is a type of person, employee is a type of person, faculty and staff are types of employee, right? Employee is a category, person is a category. You can imagine many non-person objects. You can imagine, anyway, so yes. If we think about how categories work, like, in general, categories are very, very, very important to the mental processes of human beings. Human beings think in categories rather than thinking in particular objects, right? When you walk into a room and you see a chair, you are thinking in categories. You are saying, this object is highly similar to other objects I've seen of the same type, and likely fills the same function. I can probably assume that I can plant my butt in that thing and I won't fall off, right? That is the purpose of a chair, right? We think in categories, right? Sometimes we think in categories that are a little too broad or not representative of the things that they're supposed to represent. Human beings aren't perfect. Not all categories have definite physical instantiations, right? Chair, it's easy. I can point to a chair and say, that is a chair, right? That is a monitor. This is a toy, right? But let's consider this is a toy, right? We can only call this a toy because we have a specific thing in front of us that is a toy, right? If I asked you, if I gave you a sheet of paper and I said, draw a toy, you would have to pick some particular type of toy to draw. There's no such thing as a general toy, right? Does that make sense? That's a very important concept, right? It's very similar to how there's no such thing as a general crustacean, right? Crustaceans are always lobsters or crabs or shrimp or some other particular type of crustacean. This is not true of all categories, right? But the more abstract the category becomes, the more likely that is to be the case, right? Like, you know, particularly, like, all right, let's say we have, like, a gemstone, right? Let's say we have emerald. We have an emerald in our hand. We could accurately say, this is an emerald. You can think of what an emerald looks like. You could also accurately say, this is a rock, right? You can, that is a, okay, sure, that's a rock. You can, if I gave you a sheet of paper, you could draw what a rock looked like, right? You probably wouldn't draw an emerald, but you could draw a rock. What if I asked you to draw a solid object? Right? You'd have to pick something. You'd have to pick a solid object, right? You can't just draw any old solid object. There's no, like, so one of the ways that this distinction is described is categories that are substantial versus insubstantial, right? There's no substance to the category solid object, nevertheless it's still a useful category, right? There is substance to the category rock, because we know what we mean when we say rock. I could throw a rock at someone, right? Not that I would ever do that, I'm a very nice guy, of course. If I threw a rock at someone, it would be because they deserved it. So, I'm on a bit of a tangent. Where was I? Categories. So, it is often the case that a category contributes to our knowledge of something, contributes knowledge of properties of something, without the ability to create a thing of that class, thing of that category, right? All crustaceans have certain characteristics. We know that they all have a certain number of legs. That's a property of all crustaceans. They all have 10 legs, right? So all of these, by saying a lobster is a crustacean, I'm saying a lobster has 10 legs, right? Nevertheless, the category of crustacean is empty. It has no members. It still describes reality though. So, we can do this with classes in Java. We can take a class and we can designate it as abstract, and we can say, listen, this category, this class, describes other classes. Other classes can inherit from it. However, I don't want you to ever make one of these, right? For example, a great example is our geometric object class, right? With only the information in geometric object, we don't have enough to actually draw anything, right? We need more information. Therefore, the geometric object class is something we shouldn't ever try to make an instance of. We should never have an object for that class. That's not the purpose of that class. The purpose of that class is to be a thing that other things inherit from. And that's fine. That's something we can do. Does that make sense? Going back to our crustacean class, we can create any class, we can turn any class into an abstract class by inserting the abstract keyword before the word class in the class declaration line. Public abstract class crustacean. You can see that by doing so, I've created a problem. It seems all I do with my life is create problems. When I'm not making bugs in programs, I'm making problems for students. So, what's the problem? I'm declaring a new crustacean. Crustacean, crustacean is abstract and cannot be instantiated. I'm no longer allowed to make an object of type crustacean. Does that make sense? Question?
So any object that's abstract, you can't make an object of that?
Correct. And that makes sense, right? Again, what is just a crustacean on its own? It's not a thing, right? So this is Java's way of saying, what? You want to make a crustacean? That's not a thing. So, did you have a question at the back? No,
Yeah,
I saw your hand up.
yeah, I think I got it.
Okay, you think you wrapped your head around it?
Yeah.
Okay. Well, if you tell us the question that you did have, it might be useful to other people.
So my question pretty much was, so when we use the abstract, that means we do not create a new object for that class, right?
Right.
So then I also apply for example, crustacean. So if I go to lobster class and try to create a new object from lobster, because lobster is here from crustacean, would that also apply to lobster or not?
No.
No.
Yeah. Because lobster is a regular class. It's a substantial class. We know what we mean when we say, I want a lobster object, right? Yeah. So yeah, that's actually a fairly important point. You can see this is a problem. When I clear that error, I'll still be able to line 4 will be fine. Right? Line 4 is fine. I have not removed my ability to create lobsters. So another way of saying that is the abstract property does not pass down the inheritance hierarchy. It stays in the class you apply it to. Does that make sense?
Yes.
Very good question. I'm so glad I pulled it out of you. So yeah, does this make sense? Any other questions? All right. Okay. Makes sense?
Professor,
Yes.
can you please re-explain why you said when we do the abstract class, we cannot do like a new object? Just want to write it down.
Okay. So classes are categories. Not all categories have things, real things inside the category, right? So color is a category, right? I can say, here's a category containing all things that are red, right? There's nothing in that category that's not also in a subcategory, right? I can't talk about red on its own. Red is a property of something else, right?
So is making an abstract object just turning into like a category?
Yes. Classes were categories to begin with. But they're, like, the distinction I'm trying to draw, some categories have substance, right? Some categories you can put something in that category. Some categories you can't put anything in that category. If it's the category of red, all things which are red, there's nothing you can actually put in that category. Red can't exist independent of something that is red, right? I can't, trip over a bunch of red on my way to the candy store, right? Whereas I could certainly trip over a big pile of dung beetles on my way to the candy store, right? I could trip over a lobster, but I only trip over a crustacean insofar as I've tripped over a lobster, right? So that's the difference. When you make a class abstract, you're saying, this is a category, this describes reality, but it needs more information than this. Does that make sense? Any other questions?
Is there any advantage in making a class abstract? Like, can we just not make an object with that class regardless and just not?
Excellent question. Why on earth would we need this? So there's an immediate practical sort of answer to that, which is similar to why would we ever want private methods or private anything, right? Why do encapsulation? Because a lot of languages kind of don't, right? If you look at Python, right, it kind of doesn't really do encapsulation. It does, but then it's so easy, it's trivial to get an object to cough up all its private members. It's it doesn't even have a concept of privacy. And I've accused Python enthusiasts of this over the years, right? What are you talking? Python's not a proper language. It doesn't even it doesn't have private. It doesn't even do private. You know what it does? It just name mangles. Today's not the day for the Python sucks demo, but at some point ask me for the Python sucks demo. But I talk to Python people, and I'm like, your favorite language might as well not even have private members in its classes. It's not a proper language. And 80 to 90% of the time, this response I get back is, well, why do you even need private? Right? Now, anybody who's been doing this class so far should be reasons. There are reasons. I hope there are reasons, because we had to learn this in class, right? But yeah, it's and this is an attitude among dynamic language people. My most hated nemesis, people who actually like dynamic languages. And it's yeah, okay, I guess that's a thing you could say. Why even have private in the first place? Doesn't really do anything. It's like asking, it's like saying, Niagara Falls doesn't need a fence around it. Nobody's stupid enough to jump into that thing, right? That's what they're saying when they're saying variables don't need to be private, right? So basically, abstract allows you to prevent people from making objects out of things that you don't want them to make objects out of, right?
Yeah.
That's part of what it does. Aside from all of the metaphysics stuff that I was talking about, how it maps to concepts of reality. But, and here's another thing, which is the thing that we're about to get to, it allows you to require your subclasses to do things, right? So you can also make methods abstract, right? So within an abstract class, basically making the class abstract turns on the ability to make individual methods within that abstract class abstract, right? So messing up the syntax already. So, this is an abstract method. I'm thinking like call in the Pokemon sense, as in like, just give me a string that's the noise it makes. Sure, right? So, public abstract string call. All right? You may notice something strange about this method. Anybody, aside from the abstract keyword, what's the strange thing?
There's no curly braces,
There's no curly braces. What do we have instead?
just a semicolon.
Just a semicolon. That's just the declaration line of the method. We have not provided the method body.
That just seems very complicated.
Well, welcome to Java. Did I mention there's going to be an exam? Adding this, has caused more problems. Two related problems. Let's take a look at lobster. There we go. So in the lobster class, it's actually highlighting the class declaration line. Hover over. Class lobster must either be declared abstract or implement abstract method call in crustacean. That is to say, lobster needs to provide a definition for that method. Abstract methods are methods which are required to be overridden, right? Within the definition, like, that's how they are defined. It's a method that you must override. You're not allowed to not override it, right? Okay, so let's override it. Public string call. What sound does a lobster make? Squiggle squee. Good enough, right? Everything goes away. If you want, you can throw the override tag in there. Just in case you're worried you might misspell your method name. Fine, sure. I'm required to override it. So, because I'm required to override it in every subclass, right? I'm required to override it in every subclass. This means I can basically say, oh, all crustaceans should be able to do this. But I don't have enough information to actually write the method myself, but I can say, okay, all of you crustaceans, you need to give me a definition for this, right? And it's enforced. And that's abstract methods.
So it's like a placeholder?
Yeah. Yeah, it's like a placeholder. It's like your method here, but I'm gonna make you actually do it. So you can see we cleared the error in the lobster class. We now have to go into the crab class and do the same. Public string call. Yeah. Yeah. Yeah.
You didn't add the override?
The override isn't actually required. The override is a note that you send to the compiler saying, I'm pretty sure this method overrides something. Would you mind checking to make sure it does? So it's technically, the annotation is optional. You don't, like, it's not part of the, again, we have to understand the difference between the execution semantics and the type checking semantics, right? The override doesn't do anything in terms of execution. It's a note for the type checker, right? So, yeah. So you can leave it in, you can leave it out. It's up to you. Good practice to put it in if you know you're overriding something. You'll notice that toString comes with this by default. Make sense? Does that make sense to everybody? Any questions? Yeah. You want another amusing little factoid?
What?
Having to do with that vowel combination? At one point I was studying Russian, like the language, recreationally, and that language has 12 vowels. You've got like the standard ones that we have plus another one, and then each one of the vowel sounds also has a variation where you combine it with a Y sound. So you have not only you have and a, but you also have ya and yay, and those are actual like characters, and it's a fascinating language. Gesundheit. It's a fascinating language. Fascinating to study. If you're into studying languages. Yeah. I'm not a spy. I feel I have to follow that up. I actually stopped studying it once the war broke out. And I took home, like, I had like a keyboard where like I bought the stickers to like put the Cyrillic characters, for each of the keys, and I took that keyboard home, because wouldn't do to make people around the office think that you're a Russian spy while we're at war with Russia, right? Or kind of at war with Russia, Yeah. Anyway. Yeah, okay. On we go. Let's see here. Yes, we did all of that. All right. Oh, one other thing while we're on the subject. I know that this will be very, very difficult for people, especially people seated in the back, to see on my screen at this point. But the icon changed here. Maybe you guys can see that. When you make a class abstract, you get like two little gray bars on either side of the C, so that you have an instant sort of visualization of which of your classes are abstract and which ones are concrete. By the way, concrete and abstract are the correct antonyms. So, interfaces then. So if you heard all of that business about abstract methods and you were like, well, that sounds like it might be useful actually. Require people to have certain methods? That sounds like a thing I would want to do for lots of different things. Well, there's a thing for that too. And it's called an interface. So interfaces are declared. The interface keyword is used instead of the class keyword when you're declaring one. They still kind of like behave a little bit like classes, but they're highly, highly restricted. One way you can think of an interface is that, like, you know, you have concrete classes, so stuff like lobster. You have crustacean, which is like kind of like it's got some abstract properties, but it also has some non-abstract properties, right? Interfaces are only allowed to have abstract properties, only allowed to have abstract methods, pardon me. So, they contain no real implementations of anything. All of their variables must be static, public, and final. That is to say, constants. You're allowed to store data in them, but only insofar as that data is globally available and does not change. Think math.py. All of their methods have to be abstract. Okay, sure. So, because they don't actually contain anything concrete, interfaces, you can use them differently than you use regular inheritance. You remember the property of inheritance, I hope, that all classes are only permitted to inherit from one other class in Java. I say in Java because in Python you can do multiple inheritance. Interfaces break this, this convention, right? A class may inherit from as many interfaces as it likes, but it can only extend one class, right? So we are now entering a new distinction. We are now talking about the difference between two different types of inheritance. Inheritance, according to the regular definition, we'll say extension. This is the term that Java uses. Orange extends fruit. Apple extends fruit. Chicken extends animal. Tiger extends animal. Right? Classes implement an interface. You'll know it's implementation because the arrow has changed. We have a dashed or dotted arrow. I think that's a dashed arrow. Yeah, that's a dashed arrow. We have a dashed arrow instead of a solid one. This is extension. This is implementation. Does that make sense? Sort of? Maybe? Let me show you how it works. back to our crustacean class, you'll notice when you create a new class, interface is one of the options that's listed. We will create a new interface. Let's do how to eat. That's good. Or no, something that's different between lobsters and crabs. How about gullibility? I don't know why I think that like lobsters are more gullible than crabs, but let's just go with it. Public interface gullibility. So we must say, if you are going to, or I guess not gullibility, but the gullible. Gullible. So, do that from the menu. Refactor, rename. So, within these kind of textbook examples, a lot of the time when you see an interface, what it's going to be doing is like implementing a set of methods that give you like some kind of attribute. Like a single attribute, not a whole class, right? Lobsters, we have decided, are gullible. Crabs are not gullible. So it's a mistake to say that all crustaceans are gullible because crabs are not gullible, right? However, there may be other forms of crustaceans which are gullible, right? We want to have something for that. We want them to all have this, like, something that's gullible should, you should be able to consider it gullible as a supertype of those things so that you can make, like, here's an array of all of the gullible animals, right? That excludes crabs, but if you address it up here, then that's a problem. It doesn't work. So that's why you create an interface that you can implement in each of those individual classes individually. So let's say that if something is gullible, it must have a method public abstract string fell for it. Oh yeah, and can't have curly braces. There we go. Right? So, if we make lobsters gullible, this lecture is going to be another one of those ones that would be great for like an out of context clips compilation. If we make lobsters gullible, there are a couple of those on the YouTube channel if you go digging for them, by the way. Go look in the playlists. Public class lobster extends crustacean, but implements gullible. You can implement as many things as you want. You provide a comma. You provide them separated by commas, like you would typically, right? So, public string fell for it. Return not again. There you go. And that satisfies it. We have now defined fell for it for the lobster class, thus satisfying the interface. Of course, this is a trite little in-class example. Normally, these things will have, a host of, at least a small set of methods that have to do with a particular feature. Another thing this is good for is saying this class has to have this feature, right? But it says it in such a way that, it doesn't care how the class implements it, right? It says something like, I want you to be able to add data points to yourself and then give me the average, right? And it doesn't care how you do it, right? There are two main ways of doing that, by the way. If you want a class which basically calculates an average on the number of integers that it's received or something like that, two ways to do that. One is to store everything you receive inside the class in a list or something, and then calculate the average on all of those numbers when it's asked for. That's one way of doing it. Because it's an average, the formula for average is the sum of all of the things divided by the number of all of the things, right? Sum and number, these are things that you can keep track of as you add things. You don't actually have to store all of the values as long as you keep an accurate sum and count. And that also allows you to calculate the average, right? So if you write an interface for that, it doesn't, the interface doesn't care how you fulfill it, just that you fulfill it, right? So, there are two advantages to those two approaches. If you're storing all of the data in there, then you could extend the class later with additional things like give me the standard deviation, or do other sorts of, give me what the mode and the median, other calculations, give me those on that class. If you have the data, you can do that. If you don't have the data, you can't. But it also costs storage space to store numbers. So, there's a trade-off. Always and everywhere there is a trade-off between memory and runtime, or memory and flexibility. Memory is what you pay in to gain either speed or flexibility, right? All right, go home. I'm done.